All right, guys, so the next definition in our notes is concavity. So we want to say that, oh, that pen is super fat. Okay, let's try skinnier one. So the definition is the graph of a differentiable function, let's call it y equals f of x, is, okay, we're going to define it two ways, concave up, we'll fill that out, concave down, and we will fill that down out as well. Okay, so it concaves up on an open interval. Let's call this interval I, if y prime is increasing. And that's sort of a confusing language, so we will explain that, okay, on this interval called I. Now, concave down on an open interval, and let's call it I again, if y prime is decreasing on I, which is our interval. Okay, so the language, it's slightly different. Okay, so y prime is increasing, so that's the slope of y prime. Okay, so it's not saying y prime is positive, it's saying the slope of y prime. So let's give you like a basic example here, some basic example. Let's give you a parabola. So here's our f function. Are you ready? So here's your f of x, okay? Then the first derivative, as you know already, is going to be, this derivative is 0, so it's going to be, by sketching, it looks like this. Okay, don't hold me accountable for my sketch here. Okay, so here's our first derivative. It's saying that the concavity of our graph is based on this. So when y prime, it's increasing, it's stating the derivative, okay guys, the slope. So here's y prime, okay, it's increasing, that means it's the slope of y prime, so the second derivative, okay guys. So it's saying, okay, y prime is increasing, y prime is increasing. So if it's increasing, then that means it concaves up based on our definition. Of course, look at this parabola. It's opening up. Concave up means just opening upward. Okay, so that's what it means. So don't be confused on this language where it says y prime is increasing. It's not saying the y prime is positive. That means the derivative of the first derivative. Okay, that's what it's saying. Concavity test. Are you ready? The graph of a twice differentiable function, let's call it y equals f of x, is, first one, concave up on any interval where double y prime is positive. That's gonna lead us right back to that image above. So just hold on tight. I'm gonna write concave down and we'll go back up. Okay, concave down on any interval where y prime is negative. Okay, so now let's go back to what we're talking about. So as you can see already, earlier on the definition of concavity, it says y prime is increasing. But the test down here said, hey, if you do the double derivative, it has to be positive. Positive means obviously the slope is positive. The slope of the slope is positive. And as you can see, the graph here in red, which is the first derivative, right guys? The slope, it's always positive, right? So the third derivative, guys, it's always positive. So this is positive, this is positive, this is positive, this is positive, and this is positive. So that derivative, it's always positive. So a point of inflection is a point where the graph of a function has a tangent line. Okay, so a point where it has a tangent line, what that means here is, class, is when it has a slope, okay? So far we know a point of inflection is a point where it has a slope, okay? So where it has a tangent line and where the concavity or concavity, okay, concavity changes. So where the concavity changes, what that means is another word, okay? So AKA, because we define the concavity test up above, then AKA, what this means is it is a point where y double prime, okay, so the second derivative is positive on one side and negative on the other side. So let's look back on the graph that we had sketched out above, okay? So here's what I gave you, right? The black curve, or this line right here, is the black one. Then you have the derivative, which is the blue one. Then you have a second derivative, which is the green one. So this point of inflection says where the tangent does exist, because it says here function has a tangent line, and where the concavity or concavity changes, or AKA where y prime is positive on one side and then negative on the other side, or vice versa. So let's look at it. Here's y prime, okay? So I'm not going to highlight. Y prime is the green one. Let me put that back. Okay, y prime is the green one. Can you see that there's positive one side and then negative down here? So the point of inflection is right here. Okay, so that's what it means by point of inflection. So if I were to do the derivative test, which is this line, the derivative of that point is 0. Okay, so when x is 0, okay, y is 0, so y prime is 0. So the derivative is 0 at the point of inflection. So let's do example 3. Use the graph of the function f to estimate a, f prime, and b, f prime prime are, so a, when it is 0, so f prime is 0, when f prime is positive, and when f prime is negative. Then b, it wants you to do double derivative when it's 0, and when f prime prime is greater than 0, and when f prime prime is less than 0. Okay, so here are what we are trying to accomplish. Okay, so they give you the function, which is a normal f of x. No big deal. Let's all agree that this is going to go up. Okay, so f prime is 0 is when we have the slope be 0. That's when we have your local min and local max. Another word for that is when you have a change, right? So when you have when it's changing from increase to decrease. So these are all locations of f prime being 0, the turning point, I would say. So let's call this first one be -2, okay? So x is -2 is the first time that f prime is 0. Then this one is going to be 0, so another one is 0. Then this one over here, let's, for the sake of simplicity, let's agree that's going to be at 2. So at those 3 locations is when you're going to have the derivative equals to 0. That means the slope at those points are 0, okay? Then when is the f prime greater than 0? When is it positive? Well, it's positive when it's increasing. So as you can see, it's increasing from here to here, okay? So that's my first answer. Is going to be from, that's -2 all the way to 0, and it's increasing from here to infinity. So that's another location of increasing. So that's 2 to infinity, okay? Then let's talk about when it's decreasing. When is it less than 0? The derivative is less than 0 is when the graph itself is decreasing. So there to there. So that's going to be -infinity to -2. And another location is here to here. So that's also decreasing. So that's 0. Oops, I do not want to write with the highlighter. It's going to be 0 to 2. Okay, so those are the locations of decrease in the greens. Now, the second one is talking about the second derivative. When is the second derivative 0, right? So some of you said, well, I can just go and kind of sketch out a second derivative graph. You're right, we could. So let's try that. I already have when is 0. So we can sketch out the first derivative first. Okay, so this slope right here is decreasing. So that means on this side it's below. Then the yellow is when it's increasing. So that means it's on the top. The green is when it's below. Okay, like that. Okay. So this is y prime. Okay. Now, from y prime, we can, again, do the same thing, right? When is the second derivative 0? Right here, okay? So for the sake of simplicity, we can agree that's about -1.5, okay? Another time when the second derivative 0 is right here. So, and again, I sketched this out, so it's not an exact sketch, but at least I can have a little visual. And the second one is when f prime 0 is when at x equals to 1. So those are the 2 locations is when f prime is going to be, I'm sorry, f prime prime is 0. Then when is f prime prime greater than 0? So what does that mean? I mean when the first derivative has a positive slope. So I'm gonna unhighlight some of the stuff that I highlighted before so it's not confusing, okay, because I'm about to, okay. So when is the slope positive? Would you agree that this is a positive slope? And also this is a positive slope? So those 2 locations will also answer my questions. Oops. -infinity all the way to, we said that was -1.5, and that was 1 to infinity. Okay, so those are the 2 locations that will have a positive slope for y prime, or y prime prime is positive. Now, when is y prime prime negative? I'm going to get yellow next. Here we go. So it's negative right here, right? That's a negative slope. So I'm going to write that as, looks like -1.5 to 1. And again, these are eyeballing the values. So, okay, so estimation of that. So that's example 3A. Let's go to example 3B. Should I give you a joke? Okay, let's see. A toddler joke. Here we go. Some lettuce, some eggs, and a faucet. Okay, some lettuce, an egg, I should say, and a faucet had a race. What was the result? So some lettuce, one egg, an egg, and a faucet had a race. What was the result? The lettuce came in ahead, the egg got beat, and the faucet, it's still running. Ha ha. Thank you for listening to my joke. Thank you, thank you. Take a bow. Okay. Sorry. Okay. All right, this one, it's already straight up given to you as f prime. Okay, so I'm going to be so happy answering f prime. When it's f prime equals 0, when it's f prime positive, when it's f prime negative, okay? And then part B says when is f prime prime 0, when is f prime prime positive, and when is f prime prime negative. These are all the things you have to answer, okay? So this one's F prime already, mind you, so be careful. So I don't have to do any work. I can just look wah, wah, and wah, okay? So 3 places that F prime is 0. X is -2, 1, and 3. Beautiful. Easy peasy. When is it positive? It's positive when it's above x-axis, and so is that one. Let's agree that this goes on, okay? All right, so it's going to be positive from -2 to 1 and 3 to infinity, okay? When is it negative? Let's get a green color. It's negative when it's below the x-axis. And remember, this is already f prime, so I don't even have to do any work. I just have to look at it, okay? So it's negative when it's below 0. Okay, so it's going to be from 1 to 3. So that one's awesome. That one's easy. Love these questions, okay? Then it says, well, tell me about f double prime. Well, technically, you can graph it out, but you don't really need to. So f prime prime is 0 at the turning points of f prime. So here's one is 0, and here's another one, okay? So x equals -0.8 and 2.1. We're going to use those since they already labeled those for you. When is the slope of f prime of x positive? Okay, because it's asking when is f prime prime positive. So let me unhighlight. Okay. So it's positive from here to here, okay, and positive from here to here. So I am going to go negative infinity all the way to -0.8, and I can use 2.1 to infinity. So that's when the slope of f prime is positive. Now, when is it negative? Yellow highlighter, here it comes. Okay, so it's negative from here to here. Okay, so that's going to be from -0.8 to 2.1.